Now, an inverse of a matrix is really a matrix that if you multiply by the original matrix, you get what's called the identity, which is, in matrix terms, it's a bunch of ones and zeros. Ones down the diagonals and zeros down the counter diagonal, and this is called the identity matrix. The formula for the inverse is 1 over the determinant of the matrix, so therefore that uses the determinant that we talked about in the last video, and then you flip what used to be A goes down here in the corner, so one corner and the D goes up, so they switch. The B and C stay the same, but they're now negated, so it's now negative B, negative C. It's just a formula and we apply it. So matrix A, for example, is 3, negative 1, 2, 5. Earlier we found that the determinant of A was 17. You cross multiply. 3 times 5 is 15. Negative 1 times 2 is negative 2. 15 minus negative 2 is 17. Now, to find the inverse, all we do is we put 1 over the 17 that we found earlier, 1 over the determinant, and then over here, the 5 and the 3 change places, and instead of negative 1, it's now positive 1. Instead of 2, it's negative 2. You can also write this in terms of the 1 over 17 multiplies to each of the terms. So this is 1 over 17 and 3 over 17. Both answers are acceptable. You can leave it like this or this and be fine. So let's look at matrix B. The B was 6, 3, negative 2, 2. And we already said the determinant of B in a previous video we figured out was 18. So if we want the inverse, we're going to do 1 over 18. Flip the 2 and the 6. They no longer are in the same place. They've changed. The 3 becomes negative and the negative 2 becomes positive. And we can leave it like that. That'll be an acceptable answer. I'll be fine with it. On C, as another example, the original matrix was 2, 6, negative 5, 4. We found out earlier that the determinant of C was 38. So the inverse is 1 over 38. Flip the 2 and the 4. The 6 is negative and the 5 is now positive.